Hello students, to exam review number 2. In this video I'm going to attempt to explain most of the questions. Some of them I'm going to go into details in answering them, and some of them I'm just going to give you hints and steps to answer the questions. This is the first part of the exam review. So I'm going to go to the first question. The first question here says, CCD has stated in 2017 that 57.4% of its students are first-generation college students. Suppose you sample 5 CCD students and ask if they are first-generation college students or not. Counting the number of first-generation students, first we need to create a binomial probability distribution table and then answer the questions. So the first step here is to determine the probability of success and the number of trials. I can see here that the probability of success is 57.4, which is also 0.574. The number of trials is 5, and it's very obvious from the table here. So the first step is to build the table. To build the binomial table, we're going to put the numbers of trials from 0 to 5. So the number of trials is 5, n is 5. P is equal to 57.4. So now I'm going to build a table based on this information. Equals binom dot distribution of the numbers, means you're going to click on 0, comma. The trials, we have 5, comma. The probability is 0.574, comma, false. For the binomial distribution, you're going to always say false because we want to find the probability of each number individually. And then you're going to go back and populate. Now that I created the table, I can go ahead and copy all of these numbers and paste them here. But the question asking to round these to 4 decimals, so I'm just going to go and round these to 4 decimals first. And then I will be able to copy and paste each of these numbers. Okay, after I copied and pasted everything, I can now compute the mean and the standard deviation. So the mean and the standard deviation, I know for the binomial distribution, the mean for the binomial distribution is equal to n times p, and the standard deviation for the binomial distribution is square root of n times p times 1 minus p. The variance for the binomial distribution is equal to n times p times 1 minus p. So I'm going to find the mean. The mean is equal to n, which is 5 times p, 0.574. So this is the mean. I'm going to copy it and paste it into the question. And then I'm going to find the standard deviation. The standard deviation is equal to square root of n times p, 0.574, times, open parentheses, 1 minus 0.574. And then click enter. So this is the standard deviation. I'm going to copy it and paste it right here. Now that I came up with the mean and the standard deviation, I can answer the last question. The last question says, compute the z-score for the outcome x is equal to 4. This is basically saying compute the z-score for the number 4. To compute the z-score, we need the mean. We computed it. We need the standard deviation. We computed it in the previous steps. Now, the z-score, we're going to use the function standardize. And then x, which is 4 in this case, comma the mean, comma the standard deviation. So this is the format for the standardized function that computes the z-score for any number. So standardize, x is 4, we need to standardize 4, comma the mean, we computed that, so I'm going to click on the number I computed, comma the standard deviation, I'm just going to click on the number I computed and then click enter. So basically this is the z-score for the outcome x is equal to 4. And then you're going to copy it and paste it here. Here is another question that is similar to the previous one. I'm going to get a similar question. CCA has stated in 2017 that 61.9% of the students are first-generation college students. Suppose you sample 15 students and ask if they are first-generation college students or not. Counting the number of first-generation students, we need to create a binomial distribution table and then answer the following questions. So the first step is to create the binomial distribution table. We need two things. We need the probability of success, which is 61.9, and we need the number of trials, which is 15. So I'm going to go here. N is equal to 15, and P is equal to 61.9. Let me just double check. Yes, it's 61.9, so I can write it as decimal 0.619. Always turn your percentages into decimals because percentages are not numbers. You can't work with them directly, but you can work with decimals. The number of trials is 15. That means the possible x values are from 0 to 15. So 0, 1, 2, 3. And then I'm going to select all of these, go to the edge of that as if I'm populating, and then drag it down while holding the mouse down. And then I reach 15 and then let go. Okay. Now I'm going to compute the binomial distribution for each one of these. Click on the 0 comma, the number of trials is 15, comma, the probability is 0.619, and then comma, false, because I don't want to accumulate it. And then populate. Now what I will do, I'm going to copy the first one and the last one just to make sure that I got that right. Of course, you're going to copy all of the information, but for the sake of saving some time, I'm just going to do that. So copy the first one and the last one, and then paste it into the table and check. So both of them are correct. That means in between is correct as well. Now I'm going to answer the rest of the questions. What is the probability that 11 students or less are first-generation students? So 11 students or less, that means either 11 or 10 or 9 or 8 or 7, 6, 5, 4, 3, 2, 1, 0 students are first-generation students. And that means I'm going to add all of these up since I was saying or. So the sum of 11 and less. And that is going to be the answer. I'm going to copy that and paste it into my answer box. And the answer is right. What is the probability that at least 7 students are first-generation students? At least 7, that means 7 or more. So 7 or more means I'm going to add all of these probabilities, 7 and more. So I'm going to say here, sum of 7 or more students. And then I'm going to copy that, and I will paste it into my answer box. What is the probability that 4 students will be first-generation students? 4 students are first-generation students is the number in front of 4, so I'm just going to copy that number. And I'm going to paste it over here. Since I have it already, I'm just going to plug it in here as well. And then what is the probability that between 7 and 14 students are first-generation students, inclusive of 7 and 14? There is a typo here. So 7 and 14 inclusive of 7 and 14 is equal to the sum of the probabilities from 7 to 14, including 7 and 14. So I'm going to copy that answer and I'm going to paste it into here. Okay. The last one. What is the probability that 7 students are not first-generation students? Let's think about it. So you can answer it in 2 ways. The first way, you can say, okay, if 7 students are not first-generation students, this is similar to saying 8 students are first-generation students. And that means the probability of 7 students are not first-generation students is the same as the probability of 8 students are first-generation students. Because if 7 are not first-generation students and we have only 15, that means 8 are first-generation students. So the complement rule we're going to use here. But another way to find out is to build another table with the probability of failure instead of the probability of success, which is the complement of P. So if you do that, I'm going to copy the first row, the first column, sorry, paste it here, and then I'm going to build a new table based on the probability of failure. So click on 0, comma, 15, the number of trials. Now, the probability is the complement of the probability of success, which is 1 minus 0.619, comma, false. And then populate the table, and the answer is going to be in front of 7. Notice how this is the table with the probability of failure, and this is the table with the probability of success. And now we said previously that you can approach it this way. You can say if 7 are not first generation students, that means 8 are. And those are the complement of one another. So it is either this one, or you can do it this way as well. So I'm going to copy one of them. They're identical. And I'm going to paste it over here. And they are identical. They're the same. Okay. Now, this is how you answer this question. Of course, don't forget to plug in all of your answers and check if your answers are right. Okay. Now, the next question is dealing with the normal distribution. Normal distribution, we know the properties of the normal distribution, and hopefully you went over the meaning of the normal distribution and how to compute the probabilities. So we said the area under the curve is equal to 1. We said the area under the curve represents the normal distribution. It represents the probabilities. It represents the proportion, the percentile, and etc. or percentages. Here is a question. Sales amount during lunch hour are at a local subway are normally distributed. So this is the first clue, with a mean of 7.54 and a standard deviation of 2.51. So the first step I do is I go ahead and draw the normal distribution. Here is the normal distribution, and I have the mean. The mean is always in the middle, and the mean is equal to 7.54. And the standard deviation is equal to 2.50 something. 51. Okay, now I have the mean and the standard deviation. I can answer the first question. The first question says, find the probability that a randomly selected sale was at least 8.13. At least 8.13. That means 8.13 is approximately here. At least means this is either 8.13 or more. Remember, the number line at the bottom, it has all of the sale amount during lunch hour at a local subway. Okay, so the numbers at the bottom represent the sale amount at lunch hour, during lunch hour at a local subway. So one of these numbers is 8.13, at least 8.13, it means 8.13 or more. So this is the area that represents that. And the numbers go from small to big here because this is just a number line. So this is 8.13 or more. Now, to find the area to the right of a number, we know that we can't do that directly with the normal distribution function. But we can find it anyways using this formula. If we say the entire area, which is 1, minus the area to the left of 8.13, which is this one right here. And I can compute it with norm dot distribution of 8.13, comma, the mean 7.54, comma, the standard deviation 2.51, comma, true. Then I will be able to find the blue area, which is what I am looking for. So I can't find it using norm distribution right away, but I can say 1 minus norm distribution to find the area to the right of a number. So 1 minus norm distribution of 8.13, comma, the mean 7.54, comma, the standard deviation 2.51, comma, true. And that gives me the answer. So I'm just going to copy that, and I'm going to paste it into here. a particular sale was 11.94. What is the percentile rank for this sale amount? The percentile rank is basically the area below that number. We know that the percentile is defined by the area below it, not the area above it. For example, if we want to find the 25th percentile, that means 25% of the data lies below it, and then 75% is above it. So it's defined by the area below it, not above it. So in this particular question, if we have 11.94 and we want to find the percentile rank for that number, that means we basically need to find the area below that number. 7.954, 2.51. The mean is 7.54 and the standard deviation is 2.51, and the sales amount is 11.94. 11.94 is approximately here. We want to find the percentile rank. That means we need to find the area to the left of it. This is the percentile rank for it. We note that we can find the area to the left of any number in the normal distribution using the norm distribution function. Dot distribution function of that number, comma the mean, comma the standard deviation, comma true. And then we need to do one more thing, which is turning this into a percentage. So norm dot distribution of 11.94, comma 7.54, comma 2.51, comma true. All right, now I need to turn this into percentage, so I'm gonna go ahead and turn this into percentage. I usually add 2 decimals to it just to make sure it's accurate. So 96.02. I'm gonna try this one. 2 decimals, yes. 96.02. And that is the answer for the second one. Give the sale amount that is the cutoff for the highest 25%. The highest 25% prices are usually at the right of the curve or at the top of the curve. So let me draw the picture. So here is the normal distribution again for the sales, and the mean is 7.54. The standard deviation is 2.51. The top 25% is basically this area right here, or the highest. The highest numbers are going to be at the top of the curve. This is the bottom of the curve. This is the top of the curve. So this is 25%, and we need the cutoff here. We don't know that number. What is the cutoff? Or what is the lowest price of the top 25%, in other words. All right, to find that cutoff, we know that we can use the inverse function. But the problem with the inverse function is we need the area to the left of it, not to the right of it. We can't use the 25%, basically. But we can do something else. We can still find the area to the left, which is I'm going to highlight now. So I need this area in order to figure out C using the inverse function, because that's how the inverse function works. So I know I can't find the blue area because the entire area under the curve is 100%, or 1, minus the area to the right, which is 25%, gives me 75%, or 0.75. So now that I came up with the blue area, I can find the value of C using the inverse function, norm dot inverse function of the area to the left, 0.75, comma the mean, 7.54, comma the standard deviation. So I'm going to compute it right here, equals norm inverse of 0.75, comma 7.45, 54, comma 2.51. And that is the cutoff. So the lowest price, or the lowest amount of sale in the top 25%, is this number, $9.23, approximately. So I'm going to put it right there. What is the probability that a randomly selected sale is between $6 and $8? We know how to find the area in between two numbers. So here is the normal distribution one more time. And here is 6 and here is 8. I know that the mean is 7.54 and the standard deviation is 2.51. So the area in between, to find the area in between, you're going to find the area to the left of the big number, which is the blue area. And then you're going to subtract from it the area to the left of the small number, which is this pink area right here. And we can find each one of them using the norm distribution function. So the area in between A and B is equal to norm dot distribution of the big number 8, comma, the mean, norm dot distribution of the smaller number 6, comma, the mean, comma, the standard deviation, comma, true. So I'm just going to compute that right here. Norm dot distribution of 8, comma, the mean, 7.54, comma, the standard deviation, 2.51, comma, true, close the parentheses, minus norm distribution of 6, comma, 7.54, comma, 2.51, comma, true. And that is going to be answer. I'm going to take it and paste it into the answer box. Lastly, what sale amount represents the cutoff for the middle 48% of sales? So the middle 48% of sales, I'm going to draw it first. And this is exactly in the middle. So A and B, I want to find A and B. And I have the middle area right here. I know that I can find A and B only if I have the area to the left of each one of them. And because this area is exactly in the middle, I can say that 100% minus 48% is going to give me the area in both tails. This tail and this tail. Let me say this is area E and this is area F, okay? So if I say 100% minus the middle area, I'm going to get both A and F added together. So I'm just going to do that. You can say 1 minus 0.48 as well. That is 52%. And then 52% divided into 2, because the area in the middle, I can do that. If the area isn't in the middle, I have no way to find A and B. But because of that piece of information, so because the area 48 is in the middle, I can say that the area in the tail E is equal to the area in the tail F. And as a result, if I divide 52 by 2, I can get the area in each tail. So I'm going to do that. And that is 26 in each tail. So the area here is 26% and here is 26%. Now that I have the area in each tail, I can find A and B using the inverse function. So to find A, that is the area to the left of A, and we're going to use the inverse function. So norm dot inverse of the area to the left of A, which is 26%, so 0.26, comma, the mean, which is 7.54, and the standard deviation is 2.51. That is the value for A. The value for B is basically the area to the left of B, which includes the area, the 48% plus the 26%. And I'm going to use the norm dot inverse of 0.26 plus 0.48, comma, 7.54, comma, 2.51. So that is how I'm going to compute A and B. So let me do it here. Norm dot inverse of 0.26, comma, the mean 7.54, comma, 2.51. So this is the smaller number. I'm going to paste it over here. And the bigger number, I'm going to say this is equal to, which is B, norm inverse of 0.26 plus 0.48, comma 7.54, comma 2.52, and that is going to be the top number.